All right, guys, you've had a bit of a chance to plot this graph now. So we already had done the table of values. Now, what was the first point? So x was 0, y was? No, it wasn't yawn. What was it? 7. So we go 0, 7. Then 1, 4. That's fine. What was it? 2, 2, 3. Then 3. Yep. Then 5, 12. Now we did actually do the -1 as well, so if you plotted that as well, that's fine. You'll notice that straight away it looks like that correct parabola shape. Drawing parabolas, not always the easiest. Some people like to start from the bottom and go up, and then the bottom and go up. If you get more experienced, you can actually do them in one fell swoop. I normally, when I'm doing them like this, I go from the bottom up, because the actual bit that's most important is the apex or the turning point. So I have a tendency to go up like that. Remember, it's not a point. It is actually a smooth curve at the bottom. It's not a point. It's not a V, like you were saying. It looks a bit like a V, but it actually comes down to a nice curve. If you zoomed in on it, you'd see that. Now, when they did it, they actually only asked us to do the positive values. Okay, so theoretically, we should have stopped. I'm trying to use a different colour. We should have stopped there, okay, and not done this bit. But we did it. Well, in an exam, if it says just do the positive values or between this value, only do that bit. Cool. Yeah, if it specifically says do it between this value and this value, and you don't do that, the marker's going to look at it and go, well, you're dumb. I've actually given you instructions, this value and this value. Okay, so just be aware of what the question's asking. Okay, now this one is for you guys so that you can double check your work as you're doing it. Have you guys heard of GeoGebra? You should have, because I mentioned it before I put on the recording. Okay, all right. If you use Google Chrome, at home, you can actually get this as an app on Google Chrome. Oh, no way. Really? I am dead serious. No. Yeah, and as soon as I turn off the recording, I'm going to throw something at you. Yes, you are. Yes, I am. Okay. Probably not catch it, it'll hit you in the head. You nuts. I gave you cheesecake. Shh. All right. The other thing is you can actually download this as well as a piece of software standalone. I would recommend that you use it when you're doing these. Whenever you plot a graph, I would afterwards, not when you're doing it, but afterwards, go into GeoGebra, put it in, and just double check that it looks the same. So if we go to the algebra version of this, what I've got is I've got a Cartesian plane, okay? It's just a normal Cartesian plane, same as we've always had. I can zoom out, I can zoom in, okay? Input, up here I'm going to put in what the actual example was. So what did it say? Y equals what? What was the question? Y equals what? X squared. Now, when you do x squared, I actually use shift and 6. It's a little hat. It looks like a little arrow pointing upwards. That actually turns it into an indice. Okay, y equals x squared minus 4x plus 7, correct? Okay, I hit enter. It plots the graph for me. Does that look like ours? Yes. Let's have a look. Kind of looks like ours to me. Now you'll notice I can zoom out and have a look at it and see where it goes, and you'll notice the shape doesn't change. And if I zoom in on it, you'll notice that that is a curve at the bottom of it. It's not a point, it is a curve. Now obviously depending on your scale will depend on how curved it looks, because when you get out, it does actually start to look a bit pointed. Okay, but it is a curve down there. All right? Everyone happy with that? So you've put in the table of values and now you've plotted it. All good?